Okay, so in this video, we will be solving a few programs on Java programming. Now, the first one, let's start with number one. So you have been asked to write a program in Java, WAPJ, write a program in Java to display the following terms of the series. So we simply have to display these terms up to how many terms? Up to n terms. That means if the user enters n equal to 4, I'll have to display x squared, x to the power of 5, x to the power of 6, and x to the power of 9, where n and x have to be accepted as user inputs. So let's try to decipher the logic of this series. If you observe, the first term is x squared, the third term is x to the power of 6, the fifth term is x to the power of 10. That means this is the first term, right? So this is position 1. X to the power of 6 is the third term, that is position 3. X to the power of 10 is the fifth term, that is position 5. So all your odd positions, the power of x for odd positions is increasing by 4. The power of x, what is the power of x? 2. And what is the position? 1. The next odd position is 3. The power of x is 6. So from 2 you increase it to 6, so it is increased by 4. Then from 6 it increases to 10 in the next odd position, which is 5. So in this way we can see that for odd positions the powers of x increase by 4. Now if I look at the even positions, I have to start with 5, and the powers are increasing again by 4. See, this is the second term. X to the power of 5 is the second term. Its position is 2. So I'll have to start off with x to the power of 5. Now the next even position is 4, which contains x to the power of 9. The next even position is 6, which contains x to the power of 13. So from 5, which was in second position, the power of x at position 2, my first even position, position 2, was 5. My second even position, that is position 4, is 9. So from 5 to 9, there is an increase of 4. In my third even position, which is 6, there is an increase in the power from 9 to 13. So I can see that for odd positions, you will increase the powers of x by 4. Even for even positions, you will increase the powers by 4. But for the odd positions, you will start with 2. And for even position, you will start with 5. Now with this logic in mind, let's try to write some code. So let me just copy this series so that it will be easier for me to refer to it. So I'll just copy this series and I'll place it as a comment. Now I'll get down to writing code. So I'll just save this file. Let me call this series.java, and I'll have to save it as a Java file, right? Where is it? Yeah, here it is. So I'll save it as a Java file, and now I'll paste the terms. Although the powers are not that clear, but I think you can probably understand. So this is the series that I have to print. I have to print the terms. Now I'll start with a class. Let's call this class series. Now, as usual, I'll write a main method. So I'll say public static void main, and here will go my command line arguments in the form of string array, in the form of a string array called args. And now the first thing that I'll do is I need to accept user input. I need to accept two inputs from the user. The first is the value of x, and the next is the number of terms that I want to print, that is n. Okay, so let me import the util package, and I want to import the scanner class of the util package. So it's scanner. Yeah. Now this will help me to accept user input. So let me create a scanner object first. I'll call it scan, and create an instance of the scanner object called scan, and I'll link it with my standard input device, which in this case is my keyboard. So I'll say system.in. Now I'll prompt the user. What will I prompt the user with? I'll prompt the user with a message to enter the value of x. So I'll say enter the value of x. Now seeing this statement, the user will enter a value of x, and I have to store that value in a variable called x itself. I'll store it in x, okay, so that you can understand things. you can understand things better. So I'll say int x equal to scan dot next int, and yeah, that's it. So this will enable me to accept the x input, and I need another input. I need the number of terms. So I'll just copy this and I'll say enter the number of terms. So I'll just say enter the number of terms. Now on seeing this message, so this backslash n which you see at the beginning, this will help me to print this statement, enter the number of terms, on a new line. I'll accept this number of terms in a variable called n. Now with n with me, now what I'll do is I'll have to run a loop. Now I'll run a loop starting from 1, which is my first position. X square, which you see is my first term to print, and it is at position 1. So my first position is 1. Now here my loop control variable, which is I, will denote the position of a term in my series. Now if my value of I is 1, it denotes the first position in the series, and the first position contains x square. So I have to print x square. So in this way, I will keep on denoting the positions. So I'll have to check whether the position is odd or even and proceed accordingly. So I'll say I is lesser than or equal to n and plus plus I. Now I'll check the position of I. So I'll check the value of I, which is my position. So if I mod 2, that means if I divide I by 2, if I get a remainder of 0, it denotes an even position. It denotes an even position. So let me comment this out for you. So this will denote an even position. Okay. Now with this even position, what I can do is I'll have to see what is there in my even position. The first even position is 2, which contains x to the power of 5. So I'll have to take x and raise it to the power of 5. Okay. So let me have a variable called int term. I'll define a variable called term, which will contain every x value. So whatever x is raised to the power, I'll store that in term. I'll initially give it a value of 0 because it contains nothing initially. So I'll say term is equal to, I'll use the pow function. I'll say math.pow of the value of x, and I'll raise it to the power of. Now I'll use two more variables. I'll use a variable called odd power, which will start off with a value of 2, and in fact I don't need this int. I'm declaring multiple integer variables, so I might as well separate them by commas. And my first even power is 5. So if you notice, the first odd power, this is the first term x square, and its power is 2. So the first position means position 1 has a power of 2 for x. So the first odd power, the initial odd power is 2, and the first even position is the position of x to the power of 5. So the first even power is 5. Now starting from the initial values, I'll be incrementing by 4. You can see that I have started with x to the power of 2. Then the next odd position, which is position 3, contains x to the power of 6. The next odd position, which is 5, contains x to the power of 10, and so on. Similarly, the first even position, which is 2, contains x to the power of 5. So the power is 5. So the initial power value is 5. Okay. So if my position happens to be even, I'll raise it to even power. And now remember, math.pow will return a double value. So I need the integer part of it. So I'll typecast it to int. This will enable me to get only the integer part because I need only integer part. Okay, I don't need the 0.0 which appears. So I don't need that. That's why I'm extracting only the integer part by typecasting. So this is how you typecast. Now what I do is I'll increment my even power. I'll increment my even power by 4. So I'll say even power equal to even power plus 4. Fine. Now after doing this, what I'll do is I will check if it's an odd position. So if it's not even, then it has to be odd. And if it's an odd position, I'll find my term. Again, I'll find my term and I'll increment the odd power. So I'll say term equal to int of, so I'll say odd power, right? So I'll say odd power because again, I'll do typecasting because I need only the integer part, and I'll increment my odd power variable. I'll increment my odd power variable by 4. I'll increment my odd power variable by 4. And in this way, every term will be generated. And after I'm done with the calculation of the term, after I've found the value of a term either in even position or in odd position, denoted by the else part, I can now print the value of term. So I'll say system.out.print. And what will I print? Okay, now I'll just insert a dummy println statement so that I can start printing my output from a new line. So I'll say system.out.println. So this dummy statement will start printing. Okay, sorry about that. Start printing the output from a new line. So this will help me. Now what I'll do is I'll simply print the term, and you can see that every term is separated by a plus symbol. Every term is separated by a plus symbol. So I'll keep on printing the terms. And instead of using plus, although I don't know why the plus symbol has been given, we can simply separate out these terms using a space. So I'll not use plus because in a way it would mean that I have to print the sum. So I'm not printing the sum, I'm not calculating the sum because I've not been asked to do so. So I'll separate every term by a space. In fact, I'll separate it by 2 spaces. And in this way, I can just iterate over all my positions till n and print out the values. So this will bring an end to the code. Now what I'll do is I'll run this program for you and show you how things work. So let's look at the output screen. Now the name of my class was series. So I'll say first I'll compile using the Java compiler Java C. So I'll say series.java and let's see how many outputs it throws up, how many errors it throws up. Let's see. Okay, thankfully we have no errors. Now if I try to run this, okay, it is asking me for the value of x. I'll choose a small value so that you can visualize things better. So I'll say the value of x to be 2 and I'll choose the number of terms to be 4. So now if you observe, what are my values? My values are, okay, just let me show this to you. So if you remember the series, I have printed the first 4 terms. Now what was the first term of the series? The first term, for I'm trying to print the 4 terms. That means I'll be printing up to this point. Up to this point. Okay. So the first term is x to the power of 2. What am I getting as the output? If you see, since the value of x is 2, the first term will be 2 raised to the power of 2. What is 2 raised to the power of 2? 4. What am I getting? I'm getting 4. So that's correct. Now what is the second term? The second term is x raised to the power of 5. So that is 2 raised to the power of 5. What is 2 raised to the power of 5? 32. I'm getting 32. Now, what is the next term? The next term is x to the power of 6. What is 2 raised to the power of 6? 64. And that is exactly what I'm getting. The third term is 64. And what is the fourth term? The fourth term is x raised to the power of 9. And what is 2 raised to the power of 9? Is 512. And what am I getting? I'm getting 512. So our program works well, right? So I hope you have understood this. Now what I'll do is I'll move on to another program. So let's see. Let's look at the next question. The next question is we have to display this pattern. As you can see on your screen, we have to display this pattern. So let's go ahead with it. So moving on, now the next question that we'll solve is this pattern. This is an alphabetic pattern that you can see in the form of a Floyd series. So you have A, AC, ACE. So you'll have to increment the letters by 2, right? In line number 2, you'll have to print 2 letters, but the second letter should be not B, but C. That means you'll have to skip one position at a time. Okay, so let's see. Now, since it is a matter of rows and columns, we'll need nested loops. So we'll need the outer loop for the rows and the inner loop for the columns. So let's see this. So let me just save this. Okay, that showed up unexpectedly. Let me just save this file for you. So I'll just save it as series. Save it as series2.java. Okay, now let's start. So the first thing that I will do is I'll import the util package. So I'll say java.util.scanner because I need to accept input output. And I'll say my class is series2. And I need my main method because it denotes the starting point of execution. Without main, I won't be able to execute my program. And I need to specify the list of command line arguments which will be stored if supplied in the array args. First thing first, I'll create the scanner class object. So I'll say scanner scan equal to new scanner, and I'll link it with my standard input device. So I'll say system.in. Now, as you can see in this question, it has been said that you'll have to go up to n rows, right? Now, since we have to go up to n rows, what we need to do is we need to ensure that the number of rows are available to us. So we'll have to accept the input from the user. So we'll say system.out.println. So we'll say, or let's say it's print, okay, and I'll just print it on a new line. I'll use \n and I'll ask user to enter the number of rows. Now, seeing this statement, what will the user do? The user will enter the number of rows which I'll store in n. So I'll say scan dot next int. Now this will enable me to accept integer input. Now after this, I need to start iterating. I'll have to iterate over rows and columns, right? Okay. So since I have to iterate over rows and columns, I need to write a nested loop. So my outer loop, which is controlled by the variable I, that will be for my number of rows, and this will go up to n. So as you can see, I'll just show you. Now here, for n rows, right? So if n is equal to 5, how many rows do I have to print? 1, the first row containing A, the second row containing AC, the third row containing ACE, the fourth row containing 4 terms, ACEG, and the fifth row containing 5 terms, ACEGI. So n denotes the number of rows. So if I have to print 5 rows, I'll have to go up to n. If I have to print n rows, I have to go up till n, right? If I have to print 5 rows, I'll have to go up to 5, where 5 represents the value of n. So I have to print n rows. I'm generalizing it. So I'll have to go up to n. And what I'll do is I'll run an inner loop. Now the inner loop, if you observe, that depends on my outer loop I. So I'll say j is lesser than or equal to I. It's plus j. Now if you observe, see here when I'm printing A, what is the value of I? The value of I is 1 because I'm trying to deal with the first row. And how many terms am I printing? I'm printing exactly 1 term. Remember, the inner loop, which is controlled by j, is responsible for printing my terms. Now j is going up to I. Why? Because if you observe, like I said, in my first row I'm printing 1 term, and this row number I'm getting it from the value of I itself. In the second row I'm printing 2 terms. So how many terms do I have to print? I have to print I number of terms. Why? Because the value of I in the second row is 2, and I'm printing 2 terms. Similarly, in the third row the value of I will be 3, and I'm printing 3 terms. Now using the j loop, I'm printing my terms. So j in a way is depending upon I. So when I is 1, j should correctly print 1 term. When I is 2, it should print 2 terms. When I is 3, it should print 3 terms. So in this way, j is depending upon I. So if j has to depend upon I, it has to go up to I and print I terms. Okay. So what I'll do is I'll print the terms. Now, in order to generate the terms, I'll keep a variable called term, and I'll initialize it with a value of a. Okay. Now, before initializing it here, in fact, here I'll declare, and every time I start printing a row, if you see, every row begins with A. See, the first row begins with A, the second row begins with A, the third row begins with A, and so on. So my outer loop, whenever my outer loop begins, I should initialize term with A, right? Because it is the first term of every row. So I'll start with a value of A for my terms. Now what will I do? I'll simply print out the term. So I'll say system.out.print term, and I'll separate it out with some space. And after printing the terms for a particular row, so after printing the first term, I need to go to the next term. So how do I do that? I say term is equal to term plus 2. Now you might be confused. Can I apply the plus operator on a character variable? I can, because characters are internally treated as integers. So when I say term plus 2, it means go to the second character after my current character. So if currently A contains, I mean term contains A, it will skip one character. So it will skip B and it will go to C. What is A plus 2? A plus 2 is the second term following A. So which is the second term following A? The second term following A is C. Then my term becomes C. Now from C, if I go two terms after, like I'm at C and I want to go two terms after C, then I'll say term plus 2. So it will go to C plus 2. That means it will go to E. Then again from E, if I do plus 2, it will go from E to two terms after it. That means it will go to G and so on. So this part is perfectly all right. Now what I need to do is, after printing out a particular row, I'll have to go to the next row. So in order to go to the next row, I'll simply say system.out.println. This will take me to the next row. See, after I have printed out one row, let's say I have printed out row number 2. I need to go to the third row and start printing out A, C, and E. So the J loop will help me to print out the terms for a particular row. And after I'm done with printing out the terms for a particular row using these two statements which I've highlighted, I need to go to the next line to start printing the next row. So in order to go to the next line, I'm using this println statement. Okay, fine. Now one more thing is that before I start printing, I'll again insert a dummy println statement so that my output starts printing from a new line. Okay, so this will help me. This will help the formatting to look even better. So this will bring an end to my program. Now, one thing that you must have observed is how much can be n. See, can n be any number? Can n be 50? Obviously not. Why? Because my letters of the alphabet are 26 in number. I can go only up to Z. Now, since I'm skipping two terms at a time, I can print a maximum of 13 terms, 13 letters in a particular line. So the upper value of n will be maximum 13. So what I would suggest is you rewind the last 10 seconds or last 15 seconds, which I just spoke, where I'm talking about the limiting value of n, the highest value of n. It's not that n can take any value in this case. N can only take a maximum value of 13. You can print a maximum of 13 lines. Why? Because if you try to print more than that, you will be exceeding 26 letters of your alphabet. See, you are already jumping one letter. You're skipping one letter at a time. Like you're printing A, after A, you should print B, but you're skipping B and printing C. So you're printing half the number of letters in all. So you can go up to 13 lines. You can go maximum up to 13 lines because every line can contain up to n terms, right? Every line can contain up to n terms. And here, if you observe, that the value of n can be maximum 13, because if I go anything beyond 13, I'll be trying to print beyond Z and then I'll get an error, right? Okay. I'll not get an error. I'll be getting Unicode values beyond Y, and those will not be in the range of small a to small z. Okay, so remember the highest value of n will be 13. So I need to keep a check here. So after I accept the number of rows from the user, before I proceed, I'll check. What will I check? If n, that means my number of rows, if it is lesser than or equal to 13, only then I'll be carrying out these operations which you see here. Only then I'll be carrying out these operations. Otherwise, I'll simply print a statement that system.out.print cannot print more than 13 rows because number of number of letters in the English alphabet is 26. Okay, so I'll be printing this statement and bringing my program to an end. So while asking the user to enter the number of rows, I'll print a message that not more than 13. Okay, so this will help the user to understand. Now let's try to execute our program. So what I'll do is I'll just clear the screen for you and try to execute this. So I'll say series2.java. Let me compile this for you. I just hope we don't get any errors. Okay, we have an error here. Now they're saying that there is a possible lossy conversion from int to char. Okay, since they're not allowing this conversion, we have to employ typecasting. In a way, I thought that since characters are internally stored as integers, such conversions would be flexible. But they're saying that it would lead to a lossy conversion, and they're disallowing us from going ahead. So what we need to do is we simply need to first the extract the integer value, right? So we need to extract the integer value of term. So I'll do that. Now after extracting the integer value, I'll add 2 to it, and to the result, I'll simply typecast. Okay. So let's see if this works or not. So what have I done here? If you observe, see, initially, what is the value of term? The value of term is small a. What is the Unicode value of small a? Remember, the Unicode of small a is 97. Now let's see how the calculation will proceed. So first thing what will happen is this bracket that you see, this parentheses, this will be evaluated first. So you take, so what is term now? Term is currently a, small a. Term is currently small a. Now you take its integer part. If you take its integer counterpart, you'll get 97. And to 97, you're adding 2. So what are you getting? You're getting 99. Now you're taking the character value of 99. So character value of 99 would represent the Unicode equivalent, right? The Unicode equivalent of 99. So what is the Unicode equivalent, or let's say the character equivalent of the Unicode 99? See, 97 plus 2 gives you 99. So this 99 represents a Unicode value. Now what is the character equivalent of this Unicode value 99? The character equivalent happens to be small c. So small c will be initialized to term. Small c will be placed in term and our computation will proceed normally. Now let's try to run this program. So let's do a CLS. Let's try to compile this. Now if we compile this, okay. Oh, I think we missed a semicolon here or there. Now it's saying that it's not a statement. So you just give me a moment while I make the changes. Okay, so I just found a way around my problem. That is, I can do this. Okay, see, I can apply this shorthand operator. If I apply the shorthand operator on my term variable, if I apply my shorthand operator on this term variable, then it will skip one position and go to the next character. So from A, it will go to C, from C, it will go to E, and so on. Now, let's try to execute this program. So the problem that I was facing was when I did, now you might be wondering that term plus equal to 2 is same as term equal to term plus 2. Then why is this statement not working, whereas this statement is working? Why is that so? Because see, here plus is my addition operator, and this addition operator would expect the variable on the left hand side to be the same type as the variable or the constant on the right hand side. Now see, term is a character and now 2 is an integer. So when it tries to add an integer and a constant, there is a conflict. Now since there is a conflict, it was stopping us from going ahead. But if we do this, this term plus equal to 2 essentially means that you take your term variable, whatever it be, whatever be its type, and you skip 2 positions, or you skip 1 position and go to the next point. So here the shorthand operator does the trick for us. So let's try to compile this. So let me just compile this for you. Now as you can see, we are not getting any errors. Now if I say Java series 2, try to execute it. Now if I enter, let's say 5, you see this is the output that I'm getting, and this is the expected output, isn't it? AC, ACE, ACEG, ACEGI. And that is exactly what I've got: AAC, ACE, ACEG, and ACEGI. Okay, so this is how you would go ahead with this program. Now let me try another combination. So let's say I say number of rows is 7, and you can see that we are again. So I'm skipping H and printing I. I'm skipping J and printing K. I'm skipping L and printing M. So this works fine. Now, so we are done with this program. Now let's move on to the next one. Now here we have been asked to input and store integer elements in a double dimensional array. So we have covered single dimensional arrays so far, but we haven't seen a double dimensional array. So a double dimensional array is nothing but a collection of rows and columns. In a single dimensional array, you had a single strip of elements, a single row of elements, but now we will consider an array which has 2 dimensions. That means it has the first dimension, which denotes the number of rows, and it has the second dimension, which denotes the number of columns. And we have been asked to create a double dimensional array whose size is 4 cross 4. Now this 4 cross 4 means it has 4 rows and 4 columns, and we have to input the elements in our double dimensional array and find the sum of all the elements. Again, since it is a case of rows and columns, we'll have to use nested loops. So let's see how we can do this. So I'll just create a new file, and I'll save this first so that I can get the syntax highlighting features. And I'll just call it series3.java. Okay, so let me call it series3.java and save it. Now I can proceed to solving this question. So the first thing that I need to do is I need to import the scanner class from my util package so that I can accept input. Now I'll call this file series3. I'll call the class series3, and I'll create my main method first. So as you can see, I called this class series2 as well. I'll call this series3. Now I need my main method so that I can execute this program. Without the main, I cannot execute a program. Okay, so this will be string arguments. And now the first thing that I'll do is, now it has been said that it is a 4 cross 4 matrix, a 2-dimensional array. Remember, a 2-dimensional array is also known as a matrix. So here we have been presented with a 2-dimensional array with 4 rows and 4 columns. So we can call this a matrix having 4 rows and 4 columns. Now since the dimensions have been given to us, let's first go ahead and create a double dimensional array, which is essentially a matrix. So again, before going ahead, just look at the numbers that, or look at the values that you have to fill up your matrix with. You have to fill up your matrix with integer values. That means the type of this matrix, the type of this double dimensional array will be int. So I'll say int, and I'll give the name of the array or the name of my matrix. I'll call it mat, and I'll give it 2 dimensions. So the first dimension denotes the number of rows, and the second dimension denotes the number of columns. So I'll say int mat equal to new int 4 4. So this means I have 4 rows and 4 columns. Okay, this will create my 2-dimensional array, right? So this is creates my 2D array or matrix, whatever you want to call it. So it creates my 2D array, and next I'll go on to accepting elements. So how do I accept elements? I'll accept elements by iterating over the rows and the columns. So how many rows do I have? I have 4 rows. And as you know, array indexing in Java starts from 0. So what will I do? I'll say for int I is equal to 0 and I is less than 4. And then I'll say plus plus I. So if I'm saying it's less than 4, it means I'll go from 0. 0 is less than 4. 1 is less than 4. 2 is less than 4. 3 is less than 4. So I'll go from 0 to 3, right? So this will give me 4 rows. Similarly, I'll iterate over the columns. So I'll say int j equal to 0, j is less than 4, and plus plus j. Again, I have 4 columns to deal with. That's why I'm going for this condition, j is less than 4. Either you can write I is less than 4 or j is less than 4 as I've written here, or you can also go for j is lesser than or equal to 3. It means the same thing. Okay, if you're doing less than 4, you will go up to 3, right? You cannot go beyond that, right? It's less than 4, so you can go only up to 3. So that's why it's less than 4. This helps because it's intuitive, right? Because I have number of rows as 4 and number of columns as 4, I can say less than 4. I can say less than the number of columns, or I can say less than the number of rows. So that helps intuitively. That's why I'm using less than. You can also use lesser than or equal to. It won't make any difference. Now what I'll do is I'll ask the user. So what will I ask the user? That you please enter an element. So I'll say system.out.print, and I'll do this on a new line. I'll say enter element at position. So I'll specify the position. How will I specify the position? Using the values of I and j. So I'll say enter element at position, and I'll just do some formatting so that you can understand better. So I'll say enter element at position I, and then I'll give a comma. Let me just not use the space. Enter element at position I, comma, j. Okay, so that way you will be able to understand, or the user will be able to understand the position at which he's entering the element. Okay, now after this, on seeing this statement, what will the user do? The user will enter a value, and that value has to be stored at I comma jth position. So I'll say mat of I j. So this will give me the element at I comma jth position. So initially the value of I will be 0, the value of j will be 0. So I'll get the element at position 0 comma 0. Then the value of j will be incremented by 1. So I'll get the element at position 0 comma 1. Then the value of j will be incremented to 2. So I'll get the element at 0 comma 2. Then I'll get the element at 0 comma 3. Then the j loop will terminate. Why? Because j will become 4, and this condition will be violated because 4 is not less than 4. I'll come out of the j loop, and where do I go? I go back up. I go back up in this updation part of the I loop. I go back up in the updation part of the I loop once the j loop comes to an end, and I increment the value of I by 1. So I becomes 1. Then I check the condition. Is I less than 4? Of course it is, because I is 1 and 1 is less than 4. Now since the condition is satisfied, I'll get inside the I loop, and I'll start with the j loop again. So the j loop will restart. Remember, the j loop is restarting, right? Because once a loop condition is terminated, once a loop condition is violated, you're out of the loop. And if you're going back into that loop again, it essentially means that you are restarting the loop. And every loop, remember, starts with the initialization statement. So the j variable will be initialized to 0, and you will check this condition. Is 0 less than 4? Yes. So you come inside, and now you start accepting the elements for the first row. So you will accept the element at 1 comma 0, 1 comma 1, 1 comma 2, 1 comma 3. Remember, the second row is denoted by the index of 1. The first row is denoted by the index of 0. Then the value of I will become 2. The condition of the j loop will be violated. You will come out. You will again go back to the I loop. You will increment it. And again you start with the j loop again. So you're now with a value of 2 for I. So you're going to go on inserting elements for the third row. So you will be accepting elements at 2 comma 0, 2 comma 1, 2 comma 2, 2 comma 3. In this way, the elements will be filled up in my matrix one after the other. So I'll say scan dot next int, and this will help me to accept an integer. Now after I'm done with accepting the elements, what I can do is I can run a loop. Now one thing you must have observed, one clever approach that we can apply is, we have been asked to find the sum of the elements, right? See, write a program to input and store integer elements and find the sum. Okay, the question is such that we have to input and store integer elements in a double dimensional array and find the sum. So I think we have to do it separately. Otherwise, what I would have suggested is, while you're accepting the elements, just have a sum statement here. You can simply have sum equal to sum plus mat ij. So this will be a shortcut, right? So as and when the user enters an element, you're picking it up, and summing it. So in that way, you will be avoiding extra code. Otherwise, if you're going to avoid this, if you're not going to do this, if you're going to take the input first and then proceed to calculate the sum, what will happen is you'll again have to write a pair of nested loops, because again you will have to iterate through all your elements and find the sum. So that's why now the question is such. Now it a lot depends on the examiner here. Okay. Now since this is a 15-mark question, if I end my program like this, the examiner might complain that why did you employ a shortcut? Why didn't you first store the elements and then find the sum? That's why it's better to not take any chances. But if, like, for efficiency purposes, I would say that this shortcut works fine. But for examination purposes, I would suggest that you come up with another pair. You come up with another pair of nested loops so that nobody has anything to complain about. So I'll simply just copy paste this. Again, I have to iterate over every element. I'll have to iterate over every element and just find the sum. So this part will be skipped and I'll simply have the sum statement. So after finding the sum, I can go ahead and simply print the value. So I'll say system dot out dot print the sum of the matrix. The sum of the matrix is sum, right? Now let's try to run this program. Let's just save this. So the name of the class is series3. That's the name of the file as well. I'll just clear the screen for you and I'll compile it first. So I'll say series3.java. Okay, we have an error here. They're saying that cannot find the symbol scan. Did I forget? Okay, I forgot to instantiate an object of the scanner class. I'm sorry about that. So I'll just say scanner scan equal to new scanner system.in. Okay, so this will help, right? Now let me recompile my code. So let me just recompile this. So I'll say Java C. Yes, it compiles fine. Now let me try to run it. So I'll say Java series. Now, okay, I just made one mistake. I'm sorry. It should be series 3, right? Sorry about that. So I'll simply say series 3. And yes, now I've been asked to enter. Okay, the formatting doesn't look that great. I'll just make one change. Okay. Let me just close this for you. Yeah. I should have a colon. I should have a colon so that it looks visible. So that it's visible. Okay. Otherwise, people may get confused. So let me just open up my command prompt again. So I'll just go over to my desktop. I'll clear my screen and I'll recompile this for you. So I'll say series3.java and let me run this. Now I'll say series. Okay, again I make the same mistake. I'm really sorry. I don't know what is happening. I should say Java series 3. Yeah, now see there's a colon, so things are a lot more readable, right? Now I'll try to enter these elements. The elements which you see here. So first row contains 7, 3, 4, 5 in that order. So 0, 0 is in 7. 0, 1 contains 3. 0, 2 contains 4. 0, 3 contains 5. So that 0 denotes the index of the first row. So let me fill up the first row one after the other with these elements 7, 3, 4, 5. So it should be 7. 0, 1 is 3, then it's 4, and then it's 5. Now see, I'm at 1, 0. So 1 denotes the index of the second row. So the second row starts with an index of 1, and 1, 0 denotes the first element of the second row, that is 5. The second element of the second row is 4. The third element of the second row is 6, and the fourth element of the second row is 1. So the order is 5, 4, 6, 1. So let's just insert 5, 4, 6, and 1. Now I'm at the second row. Now for the second row, I have 6, 9, 4, 2. So let's insert them. 6, 9, 4, 2. Okay. And finally, for the third row, for the last row, sorry, for the fourth row, I have 3, 2, 7, 5. So I'll say 3, 2, 7, and 5. And what is the sum? The sum of the matrix is 73, and that is what it should be. Okay. So that is how you would go about writing this program. Fine. Now what I'll do is I'll move on to another program. Now look at this. We have been asked to use the switch statement and write a menu-driven program to perform the following operations. Okay, so nowhere has it been mentioned that we have to repeat these operations. So there is no need of a loop. So the options that will be available for the user will be showed on the screen, and a user will be allowed to choose an option for only one run of the program. That means once the user enters an option, against that option, the process will take place. That means either the value of z will be printed or the Floyd's triangle will be printed. And after that, the program will come to an end. The user will not be given another opportunity to enter a value or another opportunity to enter a different choice. So that's how, because nowhere is it mentioned that you have to keep on accepting inputs. So let's go about it. So what we'll do is we'll create a new file, and let me just create a new one. Okay, why am I opening a file? I'm sorry about that. So let me just create a new file. Now I'll call this, let me just save it so that I can permit syntax highlighting. And here is my desktop. And what I'll do is I'll say series4.java. So series4.java, and I'll save it and I'll start. First things first, I'll have to import the scanner class. So I'll say import java.util.scanner, and I'll say class series4, and I'll have my main method. So public static void main string args for my command line arguments. And now I'll first instantiate an object of scanner. So I'll say scanner scan equal to new scanner, say system.in. Now after this, see, first I have to display the user a menu. See, I have to write a menu driven program. So the user has to be shown a menu. What will the menu contain? The menu will contain the first option where this formula has been given to us and we have to calculate its value, calculate the value of z. So I'll just say that for option 1, I'll put it this way. So I'll say system dot out dot print. I'll be displaying the menu this way, that I'll say number 1 is formula calculation. So if you want to perform formula calculation, then you please choose option 1. And if you want Floyd's triangle, then you please choose option 2. So option 2 will be Floyd's triangle. And I'll also keep an option 3, which will denote exit. So if the user has started this program mistakenly and doesn't want a formula calculation or doesn't want to display the Floyd's triangle, I'll allow the user to exit from the program. Okay, fine. So now on seeing this statement, now this statement is my menu. Now after displaying this statement, my job is to prompt the user for input. So I'll say system.out.print, please enter your choice. So I'll say enter your choice. Now on seeing this statement where the user has been asked to enter his choice or her choice, he will enter a value, and that value has to be stored in a variable. I'll call that variable choice. So I'll say scan dot next int. Now since it is an integer, the choice, see, the user will enter 1, which is an integer. The user will enter 2, which is an integer. The user will enter 3, which is an integer. So I'll say int choice equal to scan dot next int. Now I'll apply my switch case. So I'll apply my switch on the variable choice. That means depending on the value of choice variable, I'll apply my switch case. So the first case, the case 1, is formula calculation. Now what I'll do is, for the formula calculation, I'll write a separate function. I want to do this using user defined functions. So I'll have a function. I'll define the function later. First let me call this function. I'll have to print the value of z, right? So I'll have to print the value of z, and what I do is I simply make this function. Okay, sorry about that. I'll have a variable called z. Let me just declare a variable, a double type variable called z. Let me give it an initial value of 0.0, and I'll make z hold the return value of formula calc. I'm calling this function formula calc. Okay. Or one thing I can do is I can also pass arguments to this function. Now, what is this formula taking as arguments? This formula is taking a value of x and a value of y, where x can range from -10 to 10 with an increment of 2, and y remains constant at 5.5. Okay. So, okay, I think it's better if we do the calculation there, because in my function itself, because the value of x has to start from -10, go up to 10. So I have to run a loop, and y will remain constant. So there's nothing much I can do here. What I can do is I can simply leave the argument list empty. I think this is the best approach that we can employ. Now, after the formula is calculated, we'll print the value here. So we'll say system dot out dot print. I'll say the value of the formula is the value of z. And what you can do is, if you want to, like, I can show you one more thing. Like this part, you can see I'm storing the return value in z. You could also be a bit more sophisticated and reduce this one line. You can get rid of this one line. How? Instead of using this one line, you can simply write the function call statement here itself. So if you write f formula calc here, if you write the function call statement here, what will happen is this function will be called at this position, and whatever value is returned, that will be substituted in place of the function call which I have highlighted here. That means I'll get the output, I'll get the same output. I'll get the value of the formula is the value that is returned by this function formula calc. So you can do this as well. So this will enable you to save up on a line of code, but this may be a bit difficult for beginners to understand. So what I'll do is I'll just leave this out for now. I'll use a separate variable called z, and I'll use z to call the function formula calc, so that you can understand things better. And if you found the previous approach where I use the function call in the println statement, in the print statement itself, you can go for that as well. That is also perfectly all right. Okay. Now after I'm done with formula calculation, what should I do? I should break out of the loop. I mean, I should break out of my case. And next, otherwise it will lead to fall through. Now case 2 is where you have to calculate Floyd's triangle, right? Now, in this case, I can accept user input. So I can say that system.out.print. I need only one input, that is the number of rows. So I'll say enter number of rows. Now, on seeing this statement, the user will enter number of rows, and I'll store it in a variable called rows itself. So I'll say scan dot next int, and I'll call the function called, I'll name the function Floyd. Okay. I'll name the function Floyd, and to this function I'll pass the variable rows, and I'll make it return a value. Let me make this, in fact I don't need this function to return anything, right? Because depending on the number of rows, it will simply print out a pattern. So there's nothing much to return. So I'll define this function in such a way that it does not return a value, because I don't need it. Here in this formula calculation, the ultimate answer can be returned by the function, but here, since it's printing the pattern, there's nothing to return from this function. So I'll leave it without a return value. So its return value, since it's not returning any value, its return type when I define the function will be void. And case 3, what I'll do is for exit, I'll say that, okay, thank you for visiting, come back again later. So I'll say goodbye, and that will bring an end to case 3. And what if user enters any value outside these 3? So what are the choices available? 1, 2, and 3. If the user enters any value other than 1, 2, and 3, I'll print out invalid input, right? Anything outside 1, 2, and 3 will be considered invalid. So I'll say invalid input, and that will bring an end to my switch case. And that will also bring an end to my main method. Now I'll go on to define these functions. So first I'll define formula calc. Now as you can see, formula calc, now this main is static. So as I said that only static functions can call other static functions. So my formula calc has to be static. So I'll say static. I leave out the keyword public for now. Public means it's accessible to all. The function will be available within the class as well as outside the class for access. So okay, I think I can include public because you probably know the meaning of public now that I've mentioned it. So public means that a function is accessible. If you have a function which is public, it means that it is accessible within the class as well as outside the class. So it's public static. And what is the name of the function? The name of the function is formula calc. And as you can see, it's not accepting any arguments. So when I define the function, its parameter list will be empty. And one more thing, formula calc will be returning a value. What kind of value will it be returning? It will be returning a double value. So its return type has to be double. So it will be public static double formula calc. Okay, because as you can see, the variable on the left hand side of this function call, this is the function call. This is the function call. On the left hand side, you have z. And what is the type of z? The type of z is double. That's why the return type of formula calc has to be double. Now, what is it saying? It is saying that the x ranges from -10 to +10 with an increment of 2. So I'll have to initialize x. I'll have to initialize the variable x with -10. So I'll initialize x with -10. And it is also said that the value of y remains constant at 5.5. So I'll say double y is equal to 5.5. And it is also said that I'll have to, yeah, that's it. So I'll have to apply this formula, x to the power of 3 plus 0.5x divided by y. And the value of x will range from -10 to +10 with an increment of 2. Okay. So now since I'll have to calculate only one value, I'll have to accept so I don't need to initialize x, right? See, since it has been said that it can range from -10 to +10, I don't need to initialize it. What I need to do is I need to accept the value of x from the user. See, the value of y is fixed, but the value of x can be anything between -10 to +10. So I'll have to inform the user. So I'll inform the user to enter. So I'll say system.out.print, enter the value of x. And I'll say that it has to be from -10 to +10. Right? Now on seeing this statement, the user will enter a value for x. So I'll say int x equal to scan dot next int, and this will enable me to get the value from the user. Now one thing you must have noticed it is that this scanner object which I've created here is valid only for this function main. So since I'm accepting input here, or one thing I can do is I can okay, let it be. No, I think we can do one thing. In this formula calc, I can pass in arguments. Yeah, I think that would be better. Then the headache of defining the scanner object again is not there. And I also don't have to initialize these values. So what I'll do is in formula calc, I'll simply, before calling this function, I'll accept input here itself. So I'll say system.out.print, enter the value of x, and I'll accept x from the user. So I'll say int x equal to scan dot next int. Now this will give me the value of x. Now the value of y is fixed, and I have to calculate the value of z and return it. So I'll simply pass x and I'll pass y as arguments to the function. And instead of passing y, I can directly pass the value of 5.5, or just to make you understand things better, I'll say double y equal to 5.5, and then I'll pass y. Now this will enable you to understand things better, and I'll just give the user a message that it has to be between -10 to +10. So seeing this, the user will enter a value between -10 to +10, and the value of y is 5.5. So I can pass x and y to my function formula calc. Now see the function definition header. Which is the function definition header? This entire line. Now it will contain two parameters because it's accepting two parameters, right? It's see two arguments are being passed. X and y are being passed to formula calc. So I need to have two parameters in my function definition header. The first parameter has to be of type int because the first argument that is passed to formula calc is x, which is of type int. So I'll say int x. I can use the same name because x here in formula calc will not conflict with the x which I've defined in main because they are in two different functions, so in two different scopes. As a result, there is no question of any conflict. Okay. Now, I also need to accept the value of y. So I'll do the same thing, double y. And finally, I'll apply the formula. I'll apply this formula, right? Okay. The formula is this one, x cube plus 0.5 into x divided by y. So it will be x cube. So the value of z, so I'll have a variable called z. So double z is equal to x cube, right? So that will be x into x into x. So x times x times x plus 0.5 into x plus. So just to make you things just to make things easier for you, I'll say plus 0.5. Although I'm using a lot of extra parentheses, I can also do away with them because operator precedence will take care of the fact that 0.5 in 0.5 times x will be executed first. X times x will be executed first before the addition takes place. But still, just to make you understand, I'm using the extra pair of parentheses. And this entire thing, this is my numerator. Now this entire numerator will be divided by y. So I'll divide the whole thing by y. And this will be the value of z. So this is what it is, right? X cubed plus 0.5 into x divided by y. And what I'll do is I'll simply return the value of z. Simply return the value of z. Okay, so this will give me the value of z. Now, since it has been said that to print the value, it has not been said that you have to print the values. Although there has been an increment of 2, which makes me now there is a confusion here. It is saying that you have to print the value of z, and it is also being said that the value of x will be incremented by 2. Now, there is a confusion here, so I'll probably go ahead with this implementation. One more implementation could be where you start off, which I had initially thought of, is that you start off with a value of 10 and you keep on incrementing it by 2, the value of x, and you calculate the value, different values of z, and you keep on printing it. But then the statement should have been to print the values of z. But I don't know, like this is probably a misprint or something. For now, I'll just go ahead with this. I'll ignore the step count. I'll go ahead with this. And after this, what I have is I'll simply print the value of z. So the value of the formula is z, and Floyd's triangle. Now I have to define the function for Floyd. So again, Floyd will also be a static function. So I'll say public static void because it's not going to return any value. So I'll say public static void Floyd, and I'll say int n, which will capture the number of rows. And now I'll simply write down a nested loop because I need to, as you can see in the pattern of Floyd's triangle, I'll have to go up to n number of rows. So the outer loop will start from 1 and it will go up to n, whereas the inner loop will start from j, which is 1, and it will go up to I. The inner loop will be executed I times. I think that's pretty much clear because as you can see, initially the value of I is 1 and you're printing one term. For the second row, the value of I is 2 and you're printing two terms. Through j you're printing, so you're printing two terms means you're printing I times. Again, here in the third row, the value of I is 3, you're printing three terms, so j will go up to 3. So in general, j will go up to I terms. So every time what you'll do is you'll print a value. So what is this value? This value is starting off with 1 and it is being incremented every time by 1 as well. So I'll start off. So I'll have a variable called term. So I'll say int term equal to 1, and every time I print it, so I'll be printing it. So I'll say system dot out dot print, and I'll print the value of term, and every time I print it, I'll increment its value by 1. I'll increment its value by 1, and after I'm done printing a row, I'll print out a dummy println statement so that I can go to the next line. And this statement I'll also keep at the beginning so that my Floyd's triangle can be displayed on starting from a new line. So this will be my code for Floyd's triangle. So every time I print a term, I'll be incrementing its count by 1, because as you can see, from 1 you go to 2, then 3, 4, 5, 6. So the term will simply increment by 1 after every value is printed. That's why I'm incrementing term after every print statement. So this will take care of this. I still feel a bit uncomfortable about the fact that the way this question was put forward. It's being said that x ranges from -10 to 10 with an increment of 2. I think it's better if I make the changes, because I don't feel comfortable with this fact. Since the increment has been spoken about, I think it's better if I make the changes. So the changes will be such that I will not be accepting the value of x from the user. I don't need to pass in the value of y. I'll simply, and I don't need to return any value as well, because I'll be constantly printing the value of z. I'll be constantly printing the value of z, so nothing has to be printed here either. So I don't need this. So the formula calc function will be defined in this way. Let's say int x, I'll start off with a value of -10. In fact, what I can do is I can directly start my loop. So I'll say for int I equal to -10, or let's use the variable x so that you can understand better. And this function will not take any arguments, so the parameter list will be empty and will not return any value, so the return type will be void. I'll say x equal to -10, and x will go up to +10 with a step count of +2. As you can see here, if you observe, it has been said that there's an increment of 2. That's why I'll increment my x value by 2. And every time I do this, I'll calculate the value of z. So I'll say double z 0.0. And now I'll calculate the value of z at every step using this formula. So it's x times x times x plus 0.5 times x divided by y, which is fixed. The value of y, as they've said, remains constant at 5.5. So I'll directly place the value 5.5. Or if you want to keep it conformed with this formula, then what you can do is, that will be an extra step. You simply say y is equal to 5.5, and instead of using this constant, you use the variable 5.5. So in that way, it will be in conformation with the formula. And after you have calculated the value, you simply print it out. So you have to print it out at every step for every value of x. So you say system.out.print, and you print it on a new line. Okay. So you say the value of z is, and you print the value of z. So in this way, I think it will be better. So this makes more sense, because since it's been mentioned, the step count has been mentioned, I think it's better if we go for a loop, in spite of the fact that they've set to print only a single value of z. Okay, so now let's try to run this program and let's see how things go. So I'll just clear the screen for you, and I'll say Java C series4.java. Let's just hope we don't get any errors. Okay, we have no errors. So I'll say Java series 4. Yes, now I've been given 3 options. Now let's try all these options. Okay, let's try to exit. Let's try to enter an invalid choice. Let's say 5. So it's invalid input and the program comes to a halt. Now what if I say 3? It's saying goodbye quite correctly. Now what if I say 2? I want the Floyd's triangle. So it's asking me for the number of rows. If I enter 5, I have correctly been shown the Floyd's triangle. You can see for 5, I should go up to 15. And yes, as you can see here, this was the expected output. And that is exactly what I've got. So even if you want to try a different value and try to verify things. So if you enter 7, then also it's working fine. So from after 15, you're getting 16 to 21 and then 22 to 28. Okay. Now let's try the formula. So if I say formula calculation, okay, these are the values that I'm getting. Okay. So you can use your calculator and get the values. Obviously, as one thing is clear, the values that you will get will be symmetric, right? So you'll get negative values and you'll get the same number of positive values. And the values will exactly be the same. The only difference will be in their sign. The sign in the first case, as you can see, is all negative, and in the second case, it's all positive. Okay, so that's how you would go about writing this program. See, it's symmetric, right? Because you're going from minus 10 to plus 10. So you will have fixed number of values, fixed number of negative values, and fixed number of positive values, because the step count is also fixed to 2. So I hope this video helps you to grasp the concepts of Java. If you have any doubts, please feel free to leave it in the comment section below. And if you have any suggestions, please feel free to comment as well. I'll see you in the next one.